Welcome back, everybody. Today we're going to be talking about finding the greatest common factor of polynomial terms, a little review of the numbers, and also how to find greatest common factor of exponential terms with the same variable. First one here, we're finding the GCF greatest common factor of 30x to the 8th and 10x to the 4th. First, start off with the numbers. When you find the greatest common factor between two numbers, basically asking what's the largest number that divides evenly into both numbers. We got a 30 and a 10. A good practice is to start with the lowest number and ask yourself, does the lowest number go into the larger number? And in this case, yes, it does. If it does, then that number will be part of the GCF. In this case, 10. 10 goes into itself one time, 10 goes into 33 times. Then we come to the exponential terms. X to the 8th and x to the 4th. When finding the greatest common factor with exponential terms, it is always going to be the lowest exponent, in this case x to the 4th. Putting it all together, the greatest common factor of 30x to the 8th, 10x to the 4th is 10x to the 4th. The lower term here divides evenly into the larger term. Happens in both cases. Alright, let's look at one with three terms. Here we have 12ab to the 5th plus 60a to the 4th b squared minus 24a to the 3rd b to the 3rd. Greatest common factor, let's first focus on the numbers, 12, 60, and 24. We'll use our rule again. Let's start with the lowest number, 24, or 12. 12 goes into 24 evenly. 12 goes into 60 evenly. That tells us 12 is going to be our lowest, our greatest common factor of the numbers. Now we still have to deal with the A's and the B's. We'll focus on the A's first. Notice the exponents on each. Here we have a 3, here we have a 4, and this is a 1. We don't have to write. Go with the lowest exponent, a to the 1 power. Finally, we deal with the B's. B to the 5th, B to the 2nd, B to the 3rd. Our lowest exponent is a 2nd, that's 2 power. Putting it all together, the GCF of all three terms, 12a, b to the 2nd. Alright, now we're going to switch gears a little bit. We're going to introduce this idea of factoring. Think of factoring as the distributive property in reverse. Trying to find out which statements here are true. Now, one way to check, if you're ever given a problem like this, a way to check is to simply redistribute everything on the right side and see if it matches on the left side. But let's look at it from a factoring point of view. Factoring is when you take out the GCF and divide each term by it. Alright, we'll go through each item here to see if it is in fact true. So for A, looks like they had a GCF of g squared. Right away, this is not going to be true because they didn't take out the term with the lowest exponent. Between 4g squared and g to the 1, the GCF would have been just g. Notice this 2 here, and that makes it wrong. So this is not factored correctly, as we say. Let's try B. 9g to the 3rd plus 12 equals 3 times 3g to the 3rd plus 4. They're claiming the greatest common factor is a 3, and that is true. 9 and 12, the largest number that divides evenly into both, is 3. There's a g cubed on this term, but not on this one, therefore there's no g. And to see if we factored correctly, we will divide each of these terms by the GCF of 3 and see if it matches up. 9g to the 3rd divided by 3 is in fact 3g to the 3rd. 12 divided by 3 is 4. So this works out, this checks out. This is what we call factored correctly. Notice if we redistributed 3 to each of these terms, we would get what we have on the left. Now let's check C. We have a 24, and we have an 18. Largest number that divides evenly into both is 6. So that part is correct. We have a g squared and a g to the 4th. The lowest exponent, g squared, right here. So our GCF is correct. Let's see if they did in fact factor correctly. we'll divide both sides by g squared, 6g squared that is. 24 divided by 6 is 4. G to the fourth divided by g to the second is g to the second. 18 divided by 6 is 3. And g squared divided by g squared should be cancel out completely, but they have a g here. This should just be 4g squared plus 3, so this is incorrect. Finally, let's check B to see if it was factored correctly. 3525, largest number that divides into is 5, that's correct. G squared g to the fifth, the g squared is the greatest common factor. Let's then divide each term by 5g to the second. 35 divided by 5 is 7. G fifth divided by g2, g to the third. 25 divided by 5 is 5. G squared over g squared cancels out. D also is a true statement. It was what we call factored correctly. And I'm going to remind you, we could have taken this 5g squared, multiplied it to each item to see if it matches over here on the left side, and it does. Same thing with B. It's a way to check. Alright, let's try this scenario again. And then it's kind of asking which ones are true, which ones are in this case factored completely factored. Alright, let's go through each term. Alright, we have a 12 and a 8. Greatest common factor is a 4. We have an a to the third and an a to the 1. The GCF should have been an a. There's no a here. That key makes the first choice incorrect. Looking at B, we have a 16 and a 20. The largest number that goes into 16 and 20 is the 4. A to the fifth, a to the third, lower exponent, good. Let's go ahead and divide each thing by 4a to the third, 4a to the third. 16 divided by 4 is 4. A to the fifth, a to the third, a to the second. 20 divided by 4 is 5. A to the third, a to the third. B, it is factored correctly. Let's check C. 24 and an 18. The greatest number that divides into both is a 6. We have an a to the fourth and a nothing, so yeah, a to the 6, it's just going to be 6 by itself. Let's divide each term by 6 and see if it factored correctly. 24 divided by 6 is 4. A to the fourth divided by nothing should be a to the fourth. Aha. This a squared should be a to the fourth, making this incorrect. Last one. 30 and a 24. They're claiming the largest number that goes into both is a 3, and that's incorrect. It actually should be a 6. 6 divides into 24, 6 divides into 30. That's the largest number that goes into both. That is keeping this from being true. The only correct answer here is B. And then this last one, we're going to factor it as it says. We have 12c to the fifth, 6c to the second, minus 18. We have a trinomial of degree 5. First, let's tackle all the numbers, a 12, a 6, and an 18. We'll ask ourselves the lowest number, 6. Does 6 go into 18 and 12 evenly? It does. And then we have a c to the fifth, c second, and no c over here, so there's no variable that is part of the GCF. But this is how you can show a factoring problem. So we factor out a 6, and you can think of it as factoring out, think of it as dividing out. We'll divide each term by 6. And then whatever's left goes here in the parentheses. 12 divided by 6 is a 2. Nothing happens to the c to the fifth, so we keep that put. 6 divided by 6 is 1, and we just have a c squared left. 18 divided by 6 is 3. Alright, so we have 6 times 2c to the fifth plus c squared minus 3 is our final answer. And this is the factored form. You can always check your factoring to make sure it went correctly if you redistribute the 6. And we certainly can do that. 6 times the 2, 12c to the fifth, 6 times c squared, 6c to the second, 6 times 3, the 18. Just keep track. track of your signs. And this is the factored form of this polynomial. Thank you for watching. Hope this helped.